Okay, I think participants are there. You can write in chat box your paper ID. So I will call the authors one by one. Hello, Professor Amit. Am I audible?
Yes, sir. Yes, sir. Your voice is audible.
Okay. I'm just waiting for Professor Anand. He will join like in a minute or two. Then we will start.
Okay, sir. Okay. No, sir.
किसी में नहीं होगी सर, आपके कोई डिटेल नहीं, आपने वीडियो किया है तो लिए लिख में डालने मेरी गलती है।
Danish, sir.
We are facing, I think, some problems with this link.
Danish,
He's
sir.
saying. Yes.
Sir, Amit Gupta.
Ji.
Sir, my name is Professor Dr. Amit Kumar Gupta.
Okay. Okay. Let me get it.
Okay, sir. Okay.
I'm just texting him, so he will join. Let me call him. He shared one screenshot that he is facing a problem in connecting.
Okay, sir.
Okay, sir. Because Okay, I think there is some technical glitch from the side of Dr. Professor Anand. So I would like to take the permission of Professor Amit to start the
Okay.
session.
Yes, sir. Please start the session.
Okay. So good morning to all. Welcome to session number 25 of ICTAX 2023. First, I would like to introduce the session chairs of the day. The session chair, Professor Dr. Amit Kumar Gupta. He has obtained his PhD in computer science from a government university in Uttar Pradesh, that is Bundelkhand University, Jhansi. He had done his master's from Kurukshetra University. He is having an experience of 19 years and a vast research experience in the area of neural networks, AI, machine learning, optimization techniques, mobile computing, wireless sensor networks. He has numerous SCI and Scopus publications published under his name. So I welcome Dr. Amit to session number 25 of ICTAS 2023. So once Professor Anand will join, I will introduce him also. So I request the participant of paper ID 35. Please start your presentation.
Good morning, sir. Sir, you are referring to paper ID 335 here.
Yeah, 35.
Okay, thank you, sir. Sir, just sir, is my screen visible?
Yes, visible.
Okay. Good morning, everyone. My name is Gunjan Agarwal. I am an assistant professor in the Department of Information Technology, Rajkumar Goyal Institute of Technology, Ghaziabad, Uttar Pradesh, India. And I am here in online mode to present my paper on the topic mitigating the distributed denial of service attacks in mobile networks using machine learning models. Please allow me to start the presentation. These are the contents. Thank you, sir. These are the contents of my presentation. So moving to the first topic, abstract. My paper is about mitigating distributed denial of service attacks in mobile networks. So distributed denial of service attacks are one of the most critical cyber protection threats in today's mobile networks. These attacks utilize malicious intents of hackers and visitors from multiple sources to overwhelm a target server or community assets and potentially disrupts or disable a provider or machine. With the growth of such mobile information traffic, the superiority of network attacks on cellular networks has been increasing day by day. Conventional countermeasures, which include firewalls, which are primarily based on site visitors filtering and charge restricting, may be tough to apply in cell networks because of the dispersed and scattered nature of these networks and the broad kind of variety of devices and packages that can be related to these networks. So machine learning algorithms or models provide a promising method to discover community attacks in cell networks. These algorithms can analyze historical community information from the past and identify the current network traffic anomalies which indicate malicious conduct by someone. It can then be used to construct fashions that occur and block such activity in real time and mitigate these attacks. So, machine learning models in network attack detection in cellular networks offer an efficient and powerful way to address the problem.
Madam, what is the your contribution in this paper?
Sir, my contribution in this paper has been the basically writing of the paper and
Writing of the paper. Writing
and
of the paper.
and little bit of literature, sir. I'm the
Little bit
second
of
author of the paper, and I have contributed my knowledge of little bit machine learning and networking in this paper, and form the proposed model.
No, tell me about the proposed model.
Now, can you open your camera also? Like,
No, sir, I don't have the camera in my system. This
Okay,
is not
okay.
actually, I'm not giving the presentation from a laptop. It's a desktop.
Okay.
Madam, your
Okay.
slide is not showing.
Your slide is also not visible, ma'am, now.
Slide is not visible, sir?
Yes,
No.
yeah, because I think you stopped sharing.
No, sir, I'm not. Something must have happened. Let me see, sir. So now is it visible?
Yeah, now
Yes.
it's visible.
Okay, sir.
What proposed model, madam? Please show me.
Propose. Sir, moving on.
I request all the participants to open a camera so that we can take one screenshot for attendance. Then we can start the session. And sorry to interrupt you all. Right now, I can see that Professor Anand has also joined. So just give me a minute to introduce him. Due to some technical issues, he was not able to join at the starting of session. So, welcome, Professor Anand.
Thank you so much, sir.
Okay. And sorry for the inconvenience caused due to some technical glitch.
No
I
issue.
welcome you. Yes, sir. I welcome you to the session number 25 of ICTAS 2023.
Okay.
So, Professor Dr. Anand has a rich experience of 21 years and is currently working as a director in Noida International University, Greater Noida. Dr. Shukla has worked in several universities at the positions of HOI and Dean. Dr. Shukla has published more than 100 publications in his name, including SCI and Scopus publications. He has also authored 5 books. Dr. Shukla is known in the field of education, and he has been invited by several national and international universities for guest speakers, keynotes, and in several IEEE and external conferences. I welcome Dr. Shukla to the session.
Thank you so much, sir.
So, ma'am, now you can continue your presentation.
Okay, sir. Thank you so much, sir. So, sir, our proposed model says that if we run a machine learning algorithm.
Madam, firstly, you should go for your first slide.
First, okay, sir. Sorry, sir. So, this is the topic of my paper, mitigating the distributed denial of service attacks in mobile networks using machine learning models. This was the abstract that I was talking about earlier. Sorry for for the screen not being visible. So, should I repeat the abstract or sir move on?
You should show your novelty or the proposed model of your paper.
Okay, sir.
In which you have done some work.
Ji, sir. So the proposed architecture says that using a machine learning model, whether it is supervised or unsupervised, after training it on the data set, we can mitigate the effect of attacks on a mobile network. So we have used this diagram to show some of the working of the model. We are going through 3 phases: monitoring phase, bandwidth control phase, and detection and mitigation phase. So we monitor the traffic flow in the monitoring phase. Basically, we are monitoring the bandwidth. And if we feel that at some point in the traffic flow is exceeding the threshold value, then we increase a counter value by 1. After increasing that counter value, we initiate the second phase, which is bandwidth control phase. And in this bandwidth control phase, again, the traffic flow is tested for exceeding the maximum threshold value. If it has exceeded the maximum threshold value, then we initiate the third phase. Otherwise, we move on to the monitoring phase in the backward manner. So if we have initiated the third phase, detection and mitigation, in this we...
Hello?
Are you continue, please?
Yes, yes. So in the third phase, that is detection and mitigation phase, we again check for the attack that has been suspected to be on the network, and if the attack has occurred, then we trace the flow of the network and we try to mitigate that attack by taking some counter active measures. This is the fourth model.
Madam, this is your proposed model. So, can you tell me about the algorithm or the or the code?
No, sir, we have not actually practically implemented it. This is a theoretical concept. The practical implementation is our next step. So we have actually not implemented any algorithm.
Okay, continue, please.
Okay, thank you, sir. So we are actually, basically, sir, this is a sort of a review paper, and I'm extremely embarrassed to say that this is my first concourse paper. So I'm sorry for any, uh, mistakes and errors in the paper. So our proposed architecture is basically theoretically saying that machine learning models previously, for example, the papers that I referred to, have proposed the second point in the slide, these measures already, and we are trying to, go one step ahead of these by studying them. So theoretically, we are trying something, and the next step will be the practical implementation by using a better algorithm or modifying an algorithm. So we have compared our proposed model with these already proposed models like APMT, MAOF, and STM. These are the initial references for our paper. So machine learning has proven effective in many areas of application. So we feel that in network attack mitigation or thwarting, also machine learning has proven to be successful and can be improved in future also by using better and uh, changed algorithms, modified algorithms. So these are the existing systems with which we have compared or which we have referred to for our current proposal, and the results have shown that this is again taken as a reference. The results have shown previously also that when we use machine learning to detect an attack and try to mitigate it, even if we cannot thwart it, the results have proven to be really successful. The performance of the network has optimized and has improved significantly um, with time.
Okay, now I request to the session here, if they have any query, they can ask now. The question answer session is open now. I request session shares, if you have any query, you can ask now. Because the question answer session is open now for all. Dr. Anand, Dr. Amit?
Yes, sir.
Yes, sir. If you have any queries, please ask.
Am I audible?
Yes,
Yes, sir.
Yes, sir, you are on.
Ma'am, in your last slide, actually I was
Last.
disconnected. You
Okay,
have
sir.
compared your proposed model. Can you go on your last slide where you are comparing?
So this one was the last.
No, previous one.
This one.
Next. Next.
This one.
I haven't actually seen that slide. I was on your slide where you was comparing your, So I just want to know
Okay.
This is the slide.
Yes,
The
yes.
proposed ML model has been compared with existing
Yes, sir. These are the
autonomic
models
safety
that.
of multi-talent 5G. Acha.
Yes.
So what parameter you have taken?
Sir, we have actually taken the parameters from these papers, such as, uh, what we call it, the proposed model is using TVC, which is threshold violation counter. And that is the one mainly.
For the comparison, you have to you can discuss much more things because we are not convinced about your, on which basis you have compared, which technology you have used, which algorithm you have used, how many parameters you have used.
That is the work in progress. I'll do better.
You are not audible, ma'am.
Sir, I'm saying that is a work in progress. The algorithm that we will
That's
use.
fine. But when you have compared, compared means you already compared. So there are something, some there are some methodology that you have used definitely. So that we want to know basically.
I'm sorry, sir.
Okay. Anyway, over to you, Dani sir.
Dr. Amit, please, if you have any queries, you can ask her.
No, sir. No, sir. No questions, sir. At all.
Okay. Okay. So I would like to just clarify to all the participants that you have only like 5 to 8 minutes maximum to present your work. Please wind up your work in a limited time. And after your presentations, we will have a question answer session. Okay. So all the question and answer sessions will be taken up after your presentations. So first you please wind up your presentation in your limited time. Then our session chairs or the audience can ask questions to you. Okay. So next is like
Thank you, sir.
paper ID. Okay. Next is paper ID 341. 341 because you are having a flight. You want to present your article right now. Paper ID 341. Paper ID 341. Marhaba Shukro. If you miss, we will not be sending you paper for publication. That is your choice because this is the second time we are giving you. You make your initial presentations. No excuse will be entertained. Whether you are in pain or whatever. Okay, next participant. I think someone was having a lecture. That is paper ID. Palak Jain, you can present. Palak Jain.
Uh, Yes, sir. Good morning to everyone. My name is Palak
Please,
Jain.
Palak, please take care about the time limit, please. Okay, wind up in
Okay,
like 5, maximum 8 minutes.
okay, sir. Good morning, everyone. My name is Palak Jain. I'm born and brought up in Barkut, Uttarkashi, Uttarakhand, and I'm currently staying in Dehradun. And talking about my academics, I'm pursuing BTech in Computer Science Engineering from Graphic Era University. And this is all I want to share about me.
Uh,
Sir,
Professor Palak, you have to switch on your video as well.
Sir, actually, I'm having a network issue. If I will switch on my video, my voice will lag. That's sir. So my is my screen visible?
The screen is visible. Put your PPT on a slideshow mode.
Okay, sir. Sir, so my paper, actually my paper ID is 105 and the name is Navigating Cinematic Choices, a comprehensive examination of movie recommendation system. So these are the content that I will be covering. So movie recommendation system. They are the software tools that suggest movie to viewer based on their taste and preferences. And like these systems, they work by analyzing data about user past movie watching behavior, ratings, and other inputs to build to build user to build the profile of a user. And these it actually uses some algorithm to match the user to similar user and make personalized recommendations. Uh, s- so actually these are based on three type of filtering technique. First one is the content based filtering. In content based filtering, it analyzes the properties, behavior, attribute of a movie themselves to make recommendations. And these includes like genre, director, actor, plot, keyword, etc. To recommend the movies. And here a user profile is built, uh, and on the content of movies that the user has previously liked and rated positively. And the profile is also used to recommend similar movie to user, that is like the movie that shares similar attribute to what user has previously liked. And it has the advantage like it does not require data or another user, and it can recommend based on the attributes. uh, and it only has one limitation, like it cannot predict, it can only predict, it is not suitable for the new users. It can only predict due to the past behaviors. And the another one is the collaborating filtering. Here it makes recommendation by finding the patterns between user based on rating similarities rather than the movie attribute, like I have mentioned before, the genre, director and all. It uh, it looks like at all the user behavior, rating, like, dislike, and
You
find the
can skip the slide, madam.
okay, sir. Here is a hybrid
Skip.
filtering
You can
technique.
skip this.
This one as well.
Show your
So,
work.
so this is the main actually this is movie recommendation is it is implemented currently. So there is nothing for me to like innovate something. I have compared the different techniques that are used over the period of
How you have
time.
compared that? This is the thing we want to know. How you have
uh,
compared?
yes, sir. According to the year wise, I have compared like in
See, that's
two.
fine. This is the result of the comparison.
Mhm.
So,
So
which
I've
technique you have used for comparison? Can you please go on your previous slide? Because I think your slide has been you have done. I think with those slides.
yes, this one, sir.
Your
How
presentation
many
is over,
slides do you have?
or
Sir, actually, I think 9 or 10.
okay, you have 13 slides. Now you are on the seventh slide right now. You total have 13 slides, 1 3, I think, and you are on the ninth slide. It's still your slide, na?
Yes, sir. These are
Okay,
the
about references. Okay, that is about references.
yes, sir.
Okay,
Uh,
I think now the question answer session is open to all the session chairs. You can
Uh,
ask your questions.
that's why I asked because he's coming to the result and discussion.
Yes, yes,
But
yes.
before result, there is I think there is a slide is missing about the comparison. Means you have just discussed what the techniques are, and just after that you have shown the result.
Yes, Palak,
Yes,
what was
sir.
your paper ID? Let me check your paper. What was the paper ID?
Sir, 105.
Just wait, let me check.
Madam, what is the proposed system for your paper?
Sir, I've compared different kind of filtering that is used for movie recommendation system.
No, what is your proposed system?
Sir, actually, these are currently implemented, so there is nothing for me to actually innovate something. I can only compare different models.
Actually, madam, these are the filtering techniques you are
Yes,
showing.
sir. Yes,
They
sir.
are written in the book. But what is your proposed system? What is your novelty of your paper? I am saying about that.
Sir, algorithm. I can tell you about some algorithm that I used here.
Which one?
See, Palak ma'am, actually this is kind of an article.
Okay.
If you are going
Palak, you have
for
to
a,
update your paper and resubmit. Otherwise, it cannot be sent for publication. Okay. As per the suggestion of the session chair, what Dr. Amit is saying, and Professor Amit and Professor Anand is saying, you have to include the methodology part. Your methodology part is missing. Okay.
Sir,
How
actually
you compare? You
in
have
this
to write one paragraph.
PPT, yes,
Yes,
sir.
you have to write one paragraph
Mm.
about the methodology and one diagram of methodology. One diagram of methodology, how you compare, and one paragraph about it. Okay. And resubmit your paper by today evening.
Sir, in the paper I have mentioned everything. In PPT I have covered
That's
less.
why I had opened your paper.
Okay, sir.
Methodology is missing in your paper.
Okay,
You
okay,
just come
sir.
to the result. After discussion, you have come to the result part and your
Mm.
methodology paragraph is missing. So please add the methodology part. Okay. Otherwise,
Okay,
it will be rejected from IEEE. Okay.
okay, sir.
Okay. So just one paragraph of methodology and one diagram of methodology, how you use it. Okay.
Okay, sir.
Okay. Thank you, sir, for your feedbacks, and thank you, Palak. But submit your paper by evening. Okay.
Okay, thank you,
Any
sir.
query, you can call me on my WhatsApp number.
Okay, sir.
Next is Sonia Verma. Miss Sonia Verma, you can present your paper.
Yeah, sure, sir. So my slide is visible.
you have to start your video as well.
Okay. Wait a minute, sir.
Madam, paper ID?
So 301. So can I present now?
Yes, please.
Yeah.
Mr. If you can open your camera, we will take one screenshot as a memory
Okay,
with
sir.
you, sir.
Okay.
Thank you, sir, for opening the camera, and sorry for any inconvenience caused. Let me take a screenshot. Just wait, sir. Let me take it, and I will share with you also. Thank you, sir. Now you can just, if you want, you can close your camera. No problem, sir. Ma'am, you can start now.
Yeah, thank you, sir. A very good morning to everyone presented over here. My name is Sonia Verma. I am presenting my paper and optimize CNN and transfer learning approach for pneumonia detection at the third International Conference on Technological Advancement in Computational Science. As we all know that the 20%, according to the WHO, the 20% population are die because of the lung diseases. So my motive to present this paper is to reduce that percentage. So let's see the content. I will present abstract, introduction, then existing system, literature survey, proposed architecture, and all. Now comes to the abstract. As I told you that a lot of population, like 20% population, are affecting because of the lung diseases. As in the previous 5 to 6 years, we have seen that due to the pandemic COVID, a lot of people die because of lung disease, lung infection. So here in my paper, the main goal to for this approach is to simplify pneumonia detection so that the radiologist or expert can use this technology to fasten their process, and it will increase the efficiency also. But this system will used with the doctor preference only. So here I'm using the residual previous residual network, that is ResNet 152 V2 to train my model for to recover the pneumonia and detect the pneumonia. So using residual network, I am present. The model can determine whether a person having a pneumonia or not. And here the output of 5 different models are compared. I compare with the 5 already existing models. So the model is executed or trained using GPU, and the model is implemented on the Colab. So I have compared this model with already existing. So if we talk about the introduction here, I'm taking input as a chest medical image that is chest X-ray images. So biomedical images are analyzed and processing have a great significance in the field of machine. And as we all know, if we use the technology with doctor opinion, that it will fasten the process and increase the efficiency also. So here I have combined the hard work of doctor and the technology to improve efficiency, accuracy, and detecting a disease. So this is all about the introduction. Now let's see the existing system. In existing system approach for the detection of pneumonia and chest X-ray, limitation is that they have a bit low accuracy than my. Not there is a very big difference, and the current state of pneumonia detection in chest X-ray also falls short in accurately identifying the condition. As we all know, the lung diseases like pneumonia, lung opacity, and COVID all having a similar symptoms. So to diagnose, that is also a challenge in that. Let's see the literature survey. In the literature survey, in the first one is here the inception ResNet V2 is used. So they achieve the vector classification, but the challenge is here is information is not readily available. So these all are the literature survey. Now come to the proposed architecture. Here, as an input, I told you I take a data set in the form of chest X-ray image. Then after that, after taking input, I have split the data set into two categories. First one is training and second one is testing. Now then, as we all know that the images, the taken, the chest X-ray having the images, we have to enhance that image. So image enhancement technique are also used in this paper. Here I have resized the images, and each image was scaled down to 224 into 224 pixels before being used to train the CNN network. Then after resizing the image, I scale up the image. The image was scaled using the image data generator class. The pixel previously varied from 0 to 255 and mounted the values between the 0 and 1. After this, I have applied the data augmentation. As we know that the classes are imbalanced, so data augmentation take the perspective for each and every angle and increase the size of the class also. So a traditional data augmentation approach is used to in image pre-processing to reduce the overfitting and improve the model performance. Augmentation techniques such as zooming, shifting, and rotation were used to add variation to the data set. After data augmentation and data pre-processing, I have trained the model, and my model name is ResNet 152v2. So here in the model, I have taken the epochs are 10 and batch size is, I have taken the 32 batch size to train the model, and optimizer I used it, that is Adam, and the activation function I have used it to train this model is softmax. So and then result and the conclusion, let's see once here I have seen that we have taken the data set as a path, then load the image from the given data path, then enhance the increase images, then process the images. After that, normalized and then cascade classifier detection is also used so that the disease can be easily recognizable. So this is all about the proposed architecture, and this one is the diagram of my methodology that we have taken a data set and then pre-processing technique. Then this after pre-processing technique, we have applied the augmentation and then detect the pneumonia or the image having pneumonia or not. So this is my result. The accuracy I achieved is 99.96, and the loss function we have seen we have minimized the loss function also, that is near about 0.2. So this is all about the result and the discussion. Then after this, I have compared my result with the already existing technology. So if we talk about these VGG16, Inception, Efficient, ResNet 50V2, so these all the accuracy maintained by them is 92, 91, then 92, then 95, and my model achieved the 99.96 accuracy. So this is all about my paper.
Madam, where you collect the data set for your
Sir, I
paper?
have used the secondary source, that is Kaggle. I have collected the Kaggle.
Madam, and what are the parameters which are used in that?
Parameter to recognize the pneumonia. I have, as I told you, I have used the sir enhance the image, then epoch, and the next is I have used epoch, then batch size, then
Madam,
resize.
epoch is a number of iterations,
Yeah,
not a parameter,
iteration.
not a
Yeah.
parameter.
Yes, sir.
है ना? So
Yes, sir.
firstly you should be knowledge about how many parameters are used in your data set. First thing,
Okay,
and
sure.
how many students, how many patients you have taken the data set, how many patient you have taken the data set from the figure.
Yeah, okay, sir. Sir, shall I tell you like number of images in my data set?
नहीं, number of parameters.
Okay, so I have taken the images there are near about 5,000 and parameters I have taken. That is, I think, parameter. I will once again read about the parameters. Surely.
Okay, madam, no, not a big issue. And which type of algorithm you are using to support for your paper?
Sir, residual network 152.
Residual network 152. Is it
Yes.
used? It is used in the previous another paper?
So no, till residual 50 and 101 is used, but 152 is not used.
How the efficiency has been improved by using this parameter?
So there are there are 152 layers. So in the deep learning model, the number of layers are increased.
Actually, madam,
So,
I have also some paper. My paper are also in same Kaggle data sets, and they are SCI. So basically, for that, I am asking this type of question.
yeah, yeah, sir. There are a number as in the neural network. We all know that the number of layers increases the accuracy, the parameters, because these models are already pre-trained on the image net data set. So on that data set already having a more pre-trained accuracy. So that is why this residual 152 having more layers, and the layers are zero padding, skip connection are also there, then max pooling. So
Madam,
these yeah.
what is your role in this paper? Actually, this is a predefined algorithm. So what is your
Yeah,
role in this
sir, I
paper?
have increased one or two, I add on one or two layers. One layer I have added in this is con 2D, conventional 2D. That is having for using a pooling purpose. So, and one is flattened dense layer. Two layers I have added in this algorithm.
That is your role,
Yes, sir.
not more than that.
Sir, I have added, yeah, that is, and the sir pre-processing technique also I have added.
Okay.
So, Professor
Thank you,
Anand,
sir.
if you have any queries, Professor Anand. Okay, I think sir is having some connectivity issue. So I can request the next author. You can raise your hand if you want to present, or I will call the name.
Excuse me, sir. Hello.
Yes, yes.
Yes, I Harinder. Basically,
Yeah, please. Yeah, you
yesterday,
can start. Yeah. Yes, you can present.
yes, sir.
Okay.
Yes, because actually my presentation is scheduled for yesterday, but due to fever,
Please present
I
now. No issue. No problem. You can.
okay. Thank you, sir.
Okay.
Sir,
You
can
can
I
present
leave
now.
the session or I should
Yeah, it's
be?
your choice.
Okay, okay, thank you, sir.
So good morning to all of you. So our basically paper is dependent on the IoT dependent intelligent irrigation system with the ML dependent.
Linda, one thing. Why you have not made the presentation in the format that was provided by us?
So
First thing.
sorry, sir, for this. Basically, I got
But
ill.
next time, yeah, next time, please
Yeah.
take care. These type
Yes,
of
sir.
things
Sorry
are
for
not
this.
entertained. Okay.
Okay, sir. Sorry for this. Sir. So here I have like our group is prepared the project on IoT dependent intelligent irrigation system with ML dependent soil moisture predictions. So here is the abstract that IoT and ML dependent solutions are like currently in very usable, and to indicate with the ML technologies, it will uh, fasten our like the prediction models, which can be used further in the subsequent models. So here, the combination of machine learning and the Internet of Things may be utilized to optimize the irrigation water utilization. And also, the effectiveness of the several ML methods of estimating future soil moisture environment. And we have used here the multiple ML models. We can discuss on the further slides. So here we have an introduction. One of the main issues may countries throughout the global face is lack of fresh water, which is becoming worse over the time. As a result, is rising population and inefficient of fresh water use. And so that's why we take this topic and we worked on it. Key features is that IoT dependent intelligent irrigation system with ML dependent soil moisture prediction is a cutting edge technology solution which combines IoT with machine learning to optimize the irrigation in the landscaping. Basically, our project is combination of the IoT based infrastructure, soil moisture prediction, data collection, and training, and the further conclusion upon the model. Here is the structure which we followed for this paper. Like we have a centralized database. We implemented the soil moisture prediction algorithm, and through we get the data from the various sensors, which I indicated here: soil moisture, soil temperature, and basically it's related to the soil prospects. Here is some model how it's working. The details of the hardware which we used here, we use soil moisture sensors, DFT sensors, soil temperature sensor, and the relay circuits and the Arduino board, Raspberry Pi 3. This is the main thing which in which we predicted the models. We have multiple linear regression technique, elastic net regression, gradient boosting regression trees, and random forest regression. GBT is basically this gradient boosting regression trees is a versatile, non-parametric mathematical method for classification regression issues of gradient boosting. And here is the mathematical term which we used here in the MLP. And I want to put this data here which we predicted for the soil moisture using machine learning. We calculated the particular data like date wise, and we already predicted, like we put our ML model and we predicted some of the values which is present here. This is the temperature of the soil as they are and as they expected using ENR and MLR, these two prediction models. And here we have ENR, GBRT, and RFR soil moisture prediction versus R squared value, which we already mentioned here. Here is the soil temperature and the actual value and the predicted ML value, which is near about the same. Conclusion is that our particular ML model is subsequently in the phase to determine the particular value, and we can use it for the larger scale, and we can predict the particular soil moisture readings, because in the current scenario, soil is the major component for every irrigation part and the subsequent life. So we can use this model in the bigger aspects of the practicality, and we definitely do a lot of things when data will come. And here is the references.
Okay, sir. Sir, my one basic question is, hello, I'm audible.
Yes,
Yes, sir,
yes,
you
sir,
are
you are.
audible. Yes, sir, you are audible.
Sir, my one basic question is, you are used some data set in your paper?
No, sir, basically we put the real data set.
Okay,
We have a particular hardware system. Yeah.
Sir,
Yes, sir,
you are
we focus on the practicality. Like,
okay, sir. You are using some
yeah.
machine learning algorithm in your paper?
Yes, sir. Here I mentioned this
Yes,
algorithms.
What is the accuracy
This
rate?
multiple linear regression, elastic linear
Okay,
regression.
okay. What is the
Okay, so actually accuracy rate is yes, sir. So accuracy rate for the first model, like a multiple linear regression, it comes about to be 93%, and the other, like I already mentioned here, so I will look here. RFI we got 81% accuracy, and for the ENR we need to improve this, and we look further, like this is a 61% accuracy. So the maximum accuracy which we will get in the GBRT, yes.
GBRT. So which proposed system we should be follow for your soil moisturing?
Sir, I can't get this question, like which system, sir?
जो आपने प्रपोज सिस्टम दिया है तो उसके लिए कुछ तो एक्यूरेसी आई होगी ना,
जी सर,
है ना? तो वो बेटर कैसे है
सर? ओके सर, रेफरेंस वैल्यूज के आप बेहद पे बात कर रहे हैं?
यस
तो सर हमने बेसिकली, हमारा फोकस ही यही था कि हमने जो मतलब कि जो हमारा जो लिटरेचर सर्वे था उसमें हमने जो, मैंने यहाँ पे पुट ऑन नहीं करा है सर, तो उसमें ये था कि वो वैल्यूज जो हमारी नियर अबाउट जीबीआरटी के लिए आ रही थी, इट इज कम अबाउट टू बी दी 85 and 90%. So we improved that part, and we need to like firstly work upon the ENR and RFR algorithms. So actually I didn't put here, like as I mentioned, sir, like it is in the literature survey as I mentioned in the paper.
putting these na, so your query will be raised.
Okay, sir.
Okay, thank you.
Thank you so much, sir. Thank you.
I think Professor Anand has also joined back after there was a technical glitch. So, sir, if you have any questions, you can ask.
Good afternoon, sir.
Yes, please.
Sir, good afternoon, sir. May I present my paper? Paper number 35, paper ID?
Yes, you can.
Okay, thank you, sir.
So I think for me it's done, sir. Paper ID 547.
Yeah.
Thank you, sir.
So first of all, a very good afternoon to each and everyone. Myself, Mamta, and I'm here to present my paper that is on shining a light on solar power forecasting machine learning technique for unprecedented accuracy. So, just a second, sir. I put it on slideshow mode. In my contents, I will present some points like abstract, introduction, existing system, what are literature survey, workflow diagram, proposed model.
Ma'am, can you please start your video also?
Sir, actually there are some network issue. If I want to just switch on my camera, I just lost the network connection, sir. That's why my video is off. I tried to, sir, before some time.
Can you repeat your paper ID?
Definitely, sir. Sir, 35.
35. 35, I think it is already presented in the starting. I think your co-author presented.
No, sir. No, sir.
Not presented.
Sir, starting paper is 105. Sorry, 335.
Okay,
Ji, sir.
335. 335.
Sir, may I start?
Yes, please.
Ji. So, sir, in contents, we will discuss abstract introduction, existing system, literature survey, workflow diagram, proposed model, graphical representation of result and discussion, future enhancement, and references. So, basically, on first slide, that is for abstract. So, in abstract, we will see what is solar power forecasting. Basically, it is, first of all, it is very crucial for management of energy and for grid integration. My study explore how can we use machine learning with weather data for accurate solar power predictions. We implement data belief network that outperform other models due to their ability to learn complex pattern and reduce the manual feature engineering. They both are excel in they excel in both, in which short term and long term forecasting, and that is more accurate and more efficient as compared to pre-existent. So implementing dbn can enhance solar power forecasting system. In introduction, we can see it is a very critical component for renewable energy industry and directly influence with the efficiency and the profits for solar power plants. So solar power for actually it's a process of predicting the amount of electricity that can be generated by a solar power system in near future. Actually, solar power forecasting is crucial for grid operators, for energy provider, for renewable energy project planner, for effectively manage and integrate solar energy into electrical grid. So there are many methods and many technology that are previously used for solar power forecasting, and some methods are like clear sky model. In this model, sir, we use historical weather data and other environment parameters, and with the help of these parameters we can make an estimation to expected the solar radiation for a specific location. Any other examples are like satellite and remote sensing. Utilizing data from weather satellite and ground based remote sensing equipment, like uh, we can provide real time information on cloud covers, temperature, and solar irradiance. Next one is numeric weather prediction. With the help of numeric weather prediction, we can use complex algorithm to stimulate and predicate weather conditions. They can provide us forecast for variables like cloud cover, like wind speed, like temperatures. Some others are like machine learning and artificial intelligence. Machine learning and artificial intelligence techniques, it is increased by used for solar power forecasting. We can use this method for analyze historical data for weather patterns and for system performance to make predictions better. Next one is sky imaging and ground-based sensor, like ground-based sky imaging, like light detection and ranging. Some other models are also for prediction, like for hybrid models and for historical data. They all are the methods and technologies used for solar power forecasting. But actually, the traditional forecasting method are very struggle to capture the complex non linear abilities and interdependency of weather patterns on solar power output. Basically, what our aim of this study is to accurately using machine learning technique with a specific focus and
Now,
what
can you please give the introduction part and come to your work?
yes, definitely, sir. Sir, should I present my existing system?
Yes, you can.
Yes, sir. Actually, sir, what was in our existing system, sir, accuracy was limited in previous model. So our previous model enabled to capture the non-linear and interdependency inheritance in weather predictions. So these methods are often struggle to accurate present the complex and dynamic relationship between weather patterns and solar power output. The current solar power forecasting system is heavily on traditional method, including historical data, because they are basically dependent upon historical data and statics model, models. So in our literature survey, many research has been done by us, but our research commenced with a comprehensive review of existing literature in the field of solar power forecasting. This literature basically highlights many challenges associated with current forecasting systems and need for more advanced technique. So we identify a growing interest in machine learning approach for solar power forecasting, including artificial neural networks and support vector regression and random forest. So what now I'll present my workflow diagram. Basically, first of all, we collect the data, then we pre-process the data, then we select a model for it. After that, we train the model. After that, after training the model, we just validate the model, and in last step, we can forecast solar power. So in our model, we implement data belief network, that is a type of neural network with unique advantages. Accuracy is good. DBN are designed to learn, interpret pattern relationship in data and reducing the need for manual feature engineering. This proposed architecture are used for power forecasting leverage machine learning technique to address the limitation of existing system. So this architecture is scalable, can accommodate both short time and long term forecasting requirement. These are the result in which we can definitely see what are the model performance of this metrics. We can see like DBN, SVR, ANN, right? And yes, our resultant discussion. Our research has widely promised the result with a primary focus on performance of proposed data belief network architecture. Comparatively, analysis show that DBN model outperformed traditional model in terms of accuracy and computational efficiency. We actually engaged in through a discussion of implication of these results, emphasizing the significance of more accurate solar power forecasting for renewable energy and grid management. So what are the future scope of our paper? Actually, our study has opened the door for various possibility, like for future and what can we do with the solar power forecasting? We suggest we can explore the integration of satellite photo and resemble model to further improve prediction accuracy. We can continue our research, and that is very essential to develop forecasting model because that is not enhanced precise for prove efficiency in real world scenario, and we can add more energy management and grid integration. So these are our references. Thank you, sir.
Okay, thank you. So now the question answer session is open. I request session chairs to ask questions.
Please, sir.
Madam, your presentation is good, but my one and main question is,
Yes,
what is
sir.
your proposed system for that?
Sir, my proposed system is data. Sir, we just implemented data belief network. You can see in it.
No. Means you are getting some result, na? You are getting result from some architecture, from some proposed system. What is it?
Means from where, sir, we can just pick a database.
No. What is your model? What is your model?
Sir, data belief network is basically the model.
डेटा बिलीव मैडम कुछ तो आपका तरीका होगा कि भाई ये इनपुट है, ये मेरा डायग्राम है, इससे मेरा आउटपुट निकलेगा। ये you are showing these slides.
Yes, sir.
This is the basic slides which you can see in any machine learning or deep learning book.
Okay, sir.
What is your contribution in that? I'm saying to you.
Sir, actually, from pre-existing.
Madam, when you are getting some result, na, so these are the basic steps. Firstly, you should collect the data, pre-processing, model
Definitely,
selection,
sir.
model training. This
Training.
is but what is your model for that paper?
Okay, sir.
I
Sir,
think you have no model for that.
yes, sir. Actually, we are just doing engaging for enhance the result.
So how you can get the result when you have not a specific model?
No, sir. Actually, in our model, we can present the result with the help of this graphical representation that are the value.
Madam, you are showing the result, but भाई मेरे को कोई प्रोग्राम तो होना चाहिए कि दो नंबर के सम का प्रोग्राम है। if we have a two numbers some program, then we should give some input and after that we get some output.
Definitely, sir.
है
Yes,
ना?
sir.
So like that you have some system in which you give some input and after that you getting some output. How
Output,
you can get
definitely.
the result? How you can get the result without not having the proposed system?
Okay, sir.
I'm saying you.
Yes, sir. So definitely I look into it and next time add some more slides so that I can represent what is the system basically is. Hello, am I audible to you?
Okay, madam.
Ji, sir.
Thank you, madam.
Thank you, sir. Thanks to all of you.
Hello, sir. Can we present our paper?
Hello, sir. Can I present our paper?
Miss Savita?
Yes, sir.
Yeah.
Am I audible?
Yes, yes. You can start your presentation.
Okay. So my screen is visible.
Yes, it is visible.
Sorry, sir, I'm not able to on my camera. I think some problem is there. Shall I start, sir?
Yeah, sure. You can start.
Okay, so I'm Dr. Savita, working as Associate Professor in the Department of Agriculture, Graphicera Hill University. And my co-author is Dr. Prince Vimal. He is from Computer Science from the same university. And I'm going to present a paper on the topic integrating IoT-based environmental monitoring and data analytics for crop scientific. Basically, we have grown 2 crops in the agriculture farm with the application of IoT. So this is my abstract that in the abstract I have written that the integration of Internet of Things technology in smart agriculture management has emerged as a promising approach to address the challenges like disease problem, insect pest problem, as well as the problems related to the environment that occurs during the cultivation of a particular crop. So here we have taken only 2 crops, that is tomato and pea. And tomato is basically grown in spring summer season, while pea is grown in the winter season. And then we deployed different sensors. So I'll discuss it later on. So this is the introduction. So Internet of Things has emerged as a transformative technology which can be used to improve the quality as well as the production or in terms of yield of the crop. So here these are the advantages of IoT in smart agriculture system. So we can get the better crop quality in terms of fruit size, fruit shape and quality, fruit taste. And then the solution via data analytics can be also included in this, and we can use the sensor technology. Even the drone technology can also be used nowadays, which is widely used on a larger area to control so many problems related to agriculture cultivation. Then precision agriculture is the best solution for all the problems in agriculture, and we can get the more yield in by using these sensors to monitor the environmental fluctuations which occurs during the crop cultivation. And we can regular monitoring the crop through sensors. So the existing system, what we are using nowadays in agriculture, we are applying all the chemicals manually through labors, and actually this job which requires more labors to apply all the chemicals to do all the intercultural operations required during vegetable or other crop cultivation. So it will so if we integrate the IoT system in agriculture, then it will reduce the requirement of labors. It reduce the reliance on the labors, and we generally adjust the planting time in agriculture, in commercial agriculture, as per the temperature requirement of the crop. We can adjust the sowing time or planting time of the crop. But if we have the sensor technology, if we use the sensors in the field, then we can manipulate the temperature, and finally we can enhance the crop yield. And watering can also be done if because we use the different soil moisture based sensors which sense the soil moisture level at different levels. So if we know if the soil moisture level goes down, then we can apply the irrigation to control all the water deficiency related problems in the crop, because there are so many disorders caused by the water scarcity or water excess also, that is water which creates water logging condition that can be minimized by using the sensor technology. And even we can control the insect pest and disease problem, because nowadays the farmers are using lot of insecticides and pesticides. They don't know the right dose and amount and time of application of all the chemicals. So by drone technology, we can apply the chemicals on a particular area which is infected by a particular disease or infested by a particular insect pest. So that can be easily managed without the requirement of labors. So these are the advantages, and then this is the literature reviews. I'm not going to discuss about it. So what we have done in this paper or in this study, so we have grown tomato in spring summer season, and we deployed 3 sensors, that is soil moisture sensor and temperature sensor and relative humidity sensors, and then we have collected the data for both the crops. And this is the image of this test site, and this is the data which we obtained by deploying all these 3 sensors, humidity sensors. So we got the best result at this temperature range and this humidity range and soil moisture level when the temperature was 25, because tomato is a warm season crop which requires high temperature during its cultivation. So when the temperature was 25 and the soil moisture level at that time was 54%, and the humidity, that is the relative humidity, which is the moisture content present in the atmosphere, so that was 55%. So at this temperature we got the best result in terms of yield as well as in quality. But at this temperature range, that is 27 degrees centigrade or more than that, when the temperature reaches, the relative humidity as well as soil moisture level is also increases, but it caused so many problems at this temperature range. The crops are infected by so many diseases as well as insect pests, because the high temperature and high relative humidity is more congenial for the disease development as well as insect pest problems. So, and in case of pea is actually a warm, is a cool season crop which requires low temperature during its cultivation. So, at this temperature, we got the best result, that is 20 degrees centigrade temperature, and soil moisture level is at 46% and 41% relative humidity. But again, at this temperature range, we got the good vegetative growth, means good foliage growth, the leaf growth, plant height, everything was good at this temperature range. But we got the maximum flowering and fruit set at this temperature range and relative humidity as well as soil moisture. So this was the result which I got. And this is the moisture level which you have calculated, which you have measured at each and every second. So finally, the discussion of the result, which I have already told you, that in tomato and in pea, we deployed 3 sensors by which we got the data of temperature as well as relative humidity and the soil moisture level. So at optimum temperature and low soil moisture level, we got the best result in both the crop. But yield was maximum in case of pea when the temperature is high, somewhat high, not very high. It was 23 only, 23 degrees centigrade. So at this temperature, we got the good result. So finally, conclusion, that if we integrate the IoT system in our agriculture, then we can minimize so many problems related to agriculture, like it reduce the reliance on the labors, as well as we can timely control all the problems in agriculture, so we can enhance the crop productivity. And these are my references. Thank you. Am I audible?
Yes, you are audible.
Okay.
So I request Professor Ahmed to ask the questions.
Sir, if you have
Okay,
any query,
I think they don't have any queries, so you can just stop sharing your screen, and I will be sharing a feedback form for attendance so that we can release your certificates to be in the meeting.
Okay,
we have Professor Lokesh with us. So Lokesh sir.
Sir.
Yeah, so we have Professor Lokesh from Manipal University, Jaipur. So sir, if you are comfortable, you can present your paper.
Yes, thank you, sir. My screen visible?
Yes, sir, it's visible.
Okay, thank you.
Sir, your paper ID is
357, sir.
okay.
Okay. Good morning, everyone. I am here to my present paper entitled Flexible Antenna Design for Wearable IoT Enabled Device. In this paper I am covering the main content: abstract, introduction, proposed antenna design and parameters, result and discussion, conclusion, references. So first, move on with the abstract part. In the abstract, here says, hello.
Sir, your slides are not moving, sir. Let's
Okay.
freeze. So you can put your PPT in slideshow mode.
Okay, now it is moving. Maybe
Yes, sir. Okay.
maybe some is
Okay.
difficulty
Okay,
in
sir.
slide.
Okay. Okay, sir.
Okay, thank you. Okay, in this paper, we have basically worked on the wearable device for IoT application. In the wearable IoT device, there are many frequency range that we are used. That is 2.4 gigahertz, 5 gigahertz for ISM band, for GPS versus 1.575 gigahertz, and for the IoT, for narrowband IoT application, we have used 8802 960 megahertz frequency range, and for GSM base 850 to 900 megahertz. So in 5G band, we have also used 3.3 to 3.5 gigahertz band. But in this paper, we have basically present the antenna design for 2.4 gigahertz, and that is used for the ISM band. This is the antenna is designed using the flexible substrate Roger 580. So in the introduction, basically we have all know that the market of the IoT device and wearable devices is growing exponentially. In the IoT devices, we have maximum users there that use that is flexibility and the size of compact. So according to this size of compact, we have proposed antenna that are used for the various IoT applications that are for on-body and off-body board applications. I am showing you here the basic antenna design that I am used. In the back side of the antenna, we have used the fully ground material, and in the front side of the antenna, we have used a slot antenna will be used. This antenna will be designed using Roger 580 substrate. That thickness is 20 mm. 20 mm it will be available 0.508 mm. So, or also is the human body pantheon. In human body pantheon, we have used skin, fat, muscle, and bones. These four skin layer will be used for the design the human body pantheon. These are the main parameters that we have used. So, after the simulating the antenna for on body and off body, we have first discussed in the return loss. That return loss will be get for the with the on body, that is minus 40.33 dB, and for the off body we have moved the antenna from the we will create a distance from the human 40 antenna. If the distance is 5 mm, we have get the return loss, that is minus 36.29, and we have increased this distance at 10 mm, then we will give minus 33.91 dB. That are the main comparative for on body and off body analysis of the return loss. For similar analysis, we will be done with the gain in the terms of gain. So in the terms of gain, we will be get the gain for on body, that is 6.8 dBi, and for off body, that is 7.1 and 7.24. Here we seen we have increased the distance from the human body and antenna, that will be gain will be increased, but the return loss will be decreased. So after mainly in the wearable device, the SAR value will be very important. So we will be also analyze the SAR value, that is for on body we have get the 0.881 and 0.309 for 1G and 10G. Similar for off body and similar for off body. Here we have also shown the some bend effect of the antenna, that we have bent the antenna for some different angles. Here I am showing the comparison results of this present work with previous various work. In this work, we have seen that in present work we have get the good result in the terms of reflection coefficient, SAR, and gain also. So here the data mainly conclusion in this data, we have known that the wearable IoT devices will be sparking the revolution of the antennas or the wireless communication. So in this paper, we have basically present 2.4 gigahertz wearable IoT devices that is widely used for the ISM band application. The presented flexible and wearable antenna will be designed with Roger 580 substrate, and that thickness is 0.508 mm and dielectric constant is 2.2. The size of the presented antenna is 55 into 65 into 0.508 mm cube. Or the surface current far field analysis and different analysis for on-body and off-body application analysis will be done in this paper. These are the main reference that I am used. Thank you. If you have any question, then ask to me.
Thank you, sir, for a wonderful presentation. And I request session chair, Professor Amit, if he have any query, he can ask.
No question, sir.
Okay, thank you, sir.
Thank you, sir.
So next presentation, Ishan.
Hello.
Yeah, Ishan. Yes, you can
Yes,
start your
good
presentation.
afternoon.
What is the paper ID?
It is 26.
Paper ID 26, sir.
I'll just share my screen.
Ishan, should I share my screen or?
No, can you share? Actually, I'm not able to see the
No problem. I'll
presentation.
share the screen. Hold on. Please confirm if you can see that.
Yes, yes, we can see, sir. If you, it will be there. If you can put it on like a slideshow mode.
Oh, sure. Just give me a second. I'll open my that also camera.
Okay, then we can take one screenshot also for attendance, sir. Like.
Can you see my screen?
Yes, yes, I can. Ishan, you can also take. We can take a screenshot, sir, as a memory.
Yes.
Priyan, sir, you can also open your camera. Anand, sir, you can also open a camera so we can take one screenshot for intermediate attendance as a memory clip. Priyan, sir, Professor Priyan, you can open your camera, Professor Priyan. Okay, thank you.
Thank you, Priyan.
Thank you all. So now you can start your presentation, Ishan.
Okay. Just a second. I'll share my screen. So we are two authors present here, and Professor Arvind is also here. So Ishan and Harman, both of us are here. So we'll start with the intro, and then Ishan will take over. So I'll put in the slideshow mode. So are the author, or I should say, the topic of our presentation of our paper is prediction of autism spectrum disorder. What is autism here actually? How is it related, and how can we predict that autism in early days of a child? Then we are going to have a look at that. So this is the contents of the presentation, the abstract, introduction, existing system, and literature surveys. Moving on, we will also talk about the architectures proposed. So what we are actually proposing is a methodology or a tool to tell whether a child or whether a person is suffering from is going through the condition of autism, how it actually is. It is actually a range of disorders, so it's not really, we cannot actually tell that it's a binary 1-0 thing. So it's a spectrum of disorders. They are mostly behavioral based, as mentioned here, so it becomes difficult to understand what exactly is the issue. Therefore, the abnormality in the gaze while looking at constantly at some things, we are able to find out actually what issues can be there in terms of gaze. So what we have done, we have used neural networks, both ANN and CNN, in order to understand that, and we have achieved an accuracy of 74.57% using ANN and 85.28% using CNN, which we will discuss in our architectures. So exactly, autism comprises of several mental disorders that are neurologically developed, and how exactly CNN comes into the fact that it helps us understand the dynamics of how then eye gaze would change from one specific point of view to another specific point of view. And we actually use this eye tracking method. So as we mentioned, this eye tracking is important for studying in children to understand the risk of ASD. Again, autism spectrum disorder. So several machine learning models have been used in terms for the existing systems. Some non-neural approaches like the classical machine learning models, logistic regression, support vector machine, random forest, and we have seen an accuracy of around 70% there. The neural networks obviously outperform these approaches, and there have been multiple cases where the accuracy was much more, around 83% or 81%. Subsequently, we have also used the convenient. We can also see the simple convenient architecture that is being discussed further. Literature survey a little bit, and then we'll move on. How exactly, what all surveys have been done, what all researches have been done. So the pivotal point here is the studies have also attempted to show the eye tracking to build predictive machine learning models, and there was one model that told us to that exactly highlighted the fragile X syndrome. So this one was one of the pivotal one, and another one was consisting of a smaller data set with over 17 children that was used for understanding their gaze architecture. And now my co-author Ishan will take over from here.
Hello. So the architecture that we proposed, the data set that we've used has already been used in other models as shown previously. So this data set had a total of 59 students, 59 children, and 36 of them had some autism spectrum disorder. So what we did was so the data set comprises of their eye path. So the children were made to see a video of 4 to 5 minutes, which had random objects moving around the screen, and their eye path was tracked. So how it moves along with the objects, and if it doesn't move, or if they get distracted or not. So that image data set was used in ANN and CNN. So in CNN, we were able to directly use the images, and for the ANN model, we used PCA, which is principal component analysis. So the image is converted into a specific number of principal components, which is decided by our model itself. So we tried different number of PCA values ranging from 10 to 200 and 500. So what was noticed was it increases up till 200, and after that, if we keep increasing the component analysis, then the model does not get better. So 200 to 250 was our apt value. And for the CNN model, we used the AlexNet model. AlexNet is a popular CNN model that is generally used uh, in a day-to-day basis. So we applied the AlexNet architecture to this data set and these pre-existing CNN models, and with that we were able to reach an accuracy of about 85%. So the 219 images that you see here and the 328, this was done through image augmentation. We originally had 59 images only, and then those images, after applying some data pre-processing, we synthesized it to have 2555 images, which was used as our training test and training and test data set. So this is an example of the AlexNet architecture. We used a somewhat customized version of this because this uses a lot more data. Our images were not so highly scaled, and our GPU processing power was also low. So we downsized the images. They were not 2048 images. We used 640 by 480, and they were downsized to 100 by 100 images. Yes, this shows the PCA values that we use, and the other parameters that we used in our model were early stopping. So early stopping and reduce LR, learning rate. We calculated the learning rate, and if the learning rate of the model does not increase with the epochs, the model is stopped by itself. So as you can see, the ANN model stops after 35 epochs itself. And so as it says, the accuracy increased for the first 20 epochs, and then it stagnates. So our learning rate reduces, so the model stops by itself. In the CNN model, we were able to get a test accuracy of 85.28, which was our best, with a test loss value of 44.97. This was also kept at an ideal epochs of 100, but it stops at 40 because after that the model stops the learning rate stops the learning rate reduces after 40 epochs. So for the future, what we are proposing is this same model can be used, but with a further expanded data set. We would need a larger set of children to verify this model. Right now, we have an 85% accuracy. Another thing that can be done is we could try several newer models that have come up in addition to the AlexNet architecture that we have used, and it can be used to achieve higher accuracy.
These are our references, and thank you everyone.
Okay,
Thank
sir.
you.
Okay, sir.
It was a wonderful presentation. I would like to request Session Chair, Professor Ahmed, if he has any query, he can ask the questions.
Okay, sir. Your model is good. So can you show me some code which
Sure,
are
sir.
used for your proposal system?
Sir, hold on, sir. My colleague Ishan can definitely do that. Just a second.
Yes. Should I show you the code that was used, the CNN
The-
model itself?
You can perhaps share the Jupyter notebook on the screen if it is possible.
I think Ishan, it's okay.
Okay,
No, sir,
is my screen
just
visible
wait,
now?
just wait
Because
a
we are
minute.
running short of time now because we sorry, Professor Amit, to interrupt,
Okay,
but
sir.
sir, we are running short of
Okay, sir.
time.
Okay, sir.
And
Okay, sir. Okay, sir.
understanding
Okay.
the code will take
Sir,
a little
It's
Professor
okay.
Amit, you
It's
can have a
okay.
look, sir.
It's okay. It's okay, sir. It's okay. Good.
So, Arvind, are you ready with your presentation?
Sir, Professor Arvind is with us only. He's our third
Okay,
author.
okay, that's okay. Okay, okay, fine, thank you. Sir, but please fill the feedback form before leaving this, because we had already shared the feedback form. From that, certificates will be generated.
Okay.
Okay,
Is it in the
certificates we will
chat?
mail you by tomorrow. Yeah, by tomorrow we will email all the certificates. Okay.
Can you, sir, share the link again? The feedback
Okay, I will
form
share. Just wait. I will share it again.
in the chat.
Yeah, sure. So I have shared it again. You can fill.
Thank
You
you,
all
sir.
can fill because we are going to issue the certificates to all the authors who are present in the presentation.
Okay, sir. Thank you so much.
I think all.
Thank you, sir.
Thank you.
Yeah, I think we have all
Thank you.
done. I think because I was thinking
Thank
Professor Arvind was there in the queue. So I think we have done with the presentation for today. I would like to thank Professor Anand and Professor Amit for sparing their valuable time. And we would like to have more further collaborations
Thank you, sir. Thank
with
you
you
very
all.
much, sir.
I also like to thank Professor Lokesh for his valuable and a wonderful presentation. Thank you, Lokesh, sir.
Thank you, sir. Thank you,
Hope
sir.
we will see you. Yeah, hope we will see you all next year in the next version of this conference. Thank you all.
Thank you very much, sir. Thank you once again, sir. Thank you. Thank you, sir.
So I request IT department to please stop the recording and close the meeting for today for this link. So Professor Amit, you can leave. Professor
Okay, sir.
Panyan, you can also leave. Professor Lokesh, Professor Anand, thank you.
Okay, sir. Thank you, sir.
IT team, please close the meeting for today.
So his session is completed.
Sir. Yes, sir. You can. Yes, sir. You can end the meeting, sir.